Karen Panetta is an IEEE Fellow and Dean for Graduate Education at Tufts University. She earned her Ph.D. and MS degrees from Northeastern University and a BS degree in computer engineering from Boston University. She championed STEM diversity and founded Nerd Girls, whose mission is to encourage and inspire girls that they can change their world around them by pursuing science, technology, engineering, art, and mathematics. She is also the Editor-in-Chief of IEEE Women in Engineering magazine. She has created technology to aid in cancer diagnosis, homeland security, and safety applications for first responders. And her life's commitment is to solve humanitarian challenges using technology and empowering youth to change the world. Karen, thank you so much for joining us.
Thank you. It's a pleasure to be here, Jackie.
So, did you always want to be an engineer? Were you always interested in technology, or how did you decide to pursue this career?
Well, the answer to that is no, because I didn't even know what an engineer was. And my daddy, who really wanted me to be a civil engineer, recognized when I was very young that I had the potential to do science and math. So he said, "You will be an engineer." I had no clue what it was. And one of the biggest things that he said to me is, engineering is going to give you a secure financial future. And that's important for you because you have a very expensive shopping habit. And I want you never to have to depend on anybody else to support that bad habit. I gotta add, I was a total disappointment because I did not get a degree in civil engineering. But he also recognized when I was getting out of school that computers were becoming huge. So he was like, "This computer thing and robots, I think you should get into that." So he pretty much picked it for me.
I think he was onto something. So speaking of which, what do you think is the greatest impact technology will have on our future?
Oh, I think that now that artificial intelligence and machine learning is really becoming prime time, I will say. We always had these concepts before of neural networks, but because computing itself and cloud computing and 5G and all these technologies have advanced, it's now the infrastructure to support, an investigation of pretty much huge, massive data sets and helping humans to perceive information that we never thought about. So if you think about it, I define AI as, the ability, giving us the ability to explain, explore, and expand our human knowledge base. And I think that that's going to help us develop new technology to solve world problems much faster. And if you look at the COVID vaccine, that's a prime example of how much simulation went into that rather than the old-fashioned, trial by error types of manual things that we've done.
And right before we hopped into this interview, you were telling me about that recent study done by IEEE and AI. Can you tell us a little bit more about that?
Sure. So every few years, IEEE does this fun study called the Millennial AI Survey, where they go out worldwide, like maybe 8 different countries, and ask questions about people's parents, millennial parents, how they feel about aspects of AI taking care of their children, everything from artificial hearts to would you want a health robot monitoring your child's health in school, self-driving school buses, robo nannies and babysitters, things like that. And pre-COVID, when we did this interview, the U.S., which is strange, was predominantly developing all this technology, was dead set against it. Majority of parents like, no health robots touching my kid. And after COVID, all of a sudden you say, yeah, I guess this is a great idea, because now they understand that, wow, this is a contactless technology that's going to keep my kids safe and potentially save their lives. Yes, I want this. So I think that our perspective has changed drastically since COVID, and people are becoming much more accepting of AI, especially now that they understand how it's being used, where before, it's science fiction of robots destroying the world or taking over the world. And now we have a little better examples of how it's really benefiting humanity.
And what do you think the next applications of AI are going to look like?
I think we're going to see travel, the whole travel industry, be redefined, being able to detect pathogens and contaminants along the way, Right now, you see a lot of humans have to do that cleaning and disinfecting. So I think we're going to see a lot of advances in robotics to do that for us and be able to actually know where those contaminants are. So right now they go through an area and they're just disinfecting, but how effective is it? Can you actually see or know that the germs are really gone? So I think that's one thing. Going through airports and security checks lines, we've all been there. We know that you're packed in lines and they're very crowded. Social distancing just expands you out to the front so that it's more miserable. The lines appear longer. How are we going to keep each other safe? I think that those types of applications are going to be better sensors. I'll say better IoT, sensing contaminants out there, sensing dangerous points. When was the last time this lady's room was cleaned? Things like that.
So it's probably integrating machine learning into that setup when you're sensing it, then AI working together with machine learning to do that real-time analytics on site. Is that accurate?
Sure. So there's two types. When we talk about artificial intelligence, we're really talking about training it based on experience. So I always give the analogy that if when you go to see a physician, a lot of people don't want to go see the new kid right out of school because they haven't had that vast experience of cases. You want to see the old person that's been out there for 50 years and seen every scenario out there. That's what AI has given us the capability to do. It's allowing us to look at hundreds of thousands of cases and scenarios so that you might not have ever seen it yourself, but the AI can come back and say, you know what, this is something you should be looking at. And we've done that. My own team has done that right now with COVID. So we looked at COVID x-rays versus viral pneumonia versus normal x-rays. And I'm not a biomedical engineer, but I know image processing. And it's interesting because the diversity of the quality of these images based on what part of the world they're taken on, the expertise of the radiologist, and then the analysis is so difficult. So having AI to assist us is really making a tremendous impact.
Speaking of having your own team to work with, how did you decide to become a dean? I would never even have that on my radar.
Actually, I didn't. So I would say I'm an accidental engineer and I'm an accidental dean. Most of the things that, I got into engineering. Well, the only thing that I can say that I loved about engineering was I didn't grow up with a lot of role models. Marie Curie was long gone by the time I was in school. And I think that for me, the only role models I had, Jackie, you can believe it or not, were the actresses portraying witches and genies on television. So magic to me was the engineering, like, oh, wouldn't it be really cool if I could do these types of things? So the magic to me was in all those different types of things that they could do and how they could change things. And I didn't connect it to engineering, but I already had that passion for those types of things. And as it developed, I looked past, how to help myself to build computers. That was what I was trained for. And it became to the point that how many CPUs can I design? And it wasn't until I became a professor and I was working with students that I started seeing all these real world challenges, including, of course, all the volunteer efforts, EPICS and IEEE Site, all those humanitarian projects, that I was like, wow, I can solve these problems with the skills that I have as a computer engineer. And that got me interested in these projects. And at that time, this is where the truth time, I did actually try to move up to be, an associate dean. And like all of us, we hear no quite a bit. So I heard no. And I decided, well, you know what, if they don't want me for this position, I'll just go outside and utilize my energy somewhere else where I know I can make an impact. So I focused a lot of my energies doing these humanitarian projects around the world, in India, in Malawi, you name it. And we made tremendous impacts. And all of a sudden, the whole world knows who you are because IEEE is so, such a tight-knit community, but we do such great, wonderful things that when I came back to my institution, even though I never left, it was like, wow, you did this. Wow, you did that. And then all of a sudden I was like, yeah, you should be dean.
And this is something that I've experienced or I've seen too. I've seen so many people or heard so many of my friends talk about putting in those extra hours in corporate America to rise in the ranks. And yes, that absolutely is a path forward. But my experience has been more similar to yours too, that I did extracurricular philanthropic activities on an international level. And through that, I got the leadership skills that I was then able to use in my daytime job. So it was interesting. I'm curious if you had any pushback at the time, but at the time I had so many friends and even family members questioning why I was devoting my hours to an activity I was passionate about. And it was because I believed in it, but I also believed in developing those skills and that those would have real and genuine value.
Jackie, I am so glad you brought this up because, first of all, my father, every time I'd say I'm going to this trip for IEEE, he'd say, but you're not making any money on it. There's no money. When are you going to get paid? So anything when he heard IEEE, he was like, "What? Why are you doing this?" But so that, yes, I heard that quite a bit. But I think the other thing that you brought up was, there's a career path. And matter of fact, this is the theme of the upcoming IEEE Women in Engineering magazine issue that I'm the editor-in-chief for, is that we all have this vision of this beautiful linear path to success. And it's not, it's a zigzag, right? It's a zig. Sometimes it goes down and it goes up. And I think that that's why a lot of people give up, is because we have expectations that everything is going to be linear, and life is not linear. I think we've found that out with COVID, and the skills on it. The thing I want to hit on it, because you really hit the nail on the head, was the skills I learned, the leadership skills I learned. I didn't get that on my job. I did not get the leadership skills. I didn't even get teacher training on my job. I got everything through IEEE. And people don't realize that. They're like, well, where did you get to be such a wonderful, engaging teacher? Well, they threw the books at me, literally, when I started teaching. They handed me the textbooks, say, here's your 2 classes, here's your 180 students, go teach. And there was no support. So reaching out to people at IEEE, seeing other people, all our educational activities, tutorials, and all the great resources we have. There isn't anything I can't ask. Even Robert's rules, I know how to lead a meeting, and people are like, where the heck did you learn that? Well, you go to IEEE, you're going to learn how to lead a meeting.
Oh, absolutely. Which is funny. You mentioned about you think it's going to be a straight line. With what we're seeing, within the last 10 years, especially within the last year with digital transformation, where jobs are being created that never existed before, roles are being created, the idea that we could predict what our trajectory of our career looks like, when there might be positions that we have in the future, companies that we work for in the future that don't even exist right now. It's just, I find it so dated, at least my mindset, what it was for a while there, that I thought I could predict what I'm doing 5-10 years. And so I try to build out a loose plan. But in technology, if you're in the engineering field, I feel like we have to recognize there's no way we could, because we don't know what the next steps are. So having transferable skill sets really is where it makes sense.
Absolutely. And the other thing, Jackie, is, you bring it up, is people, like, I'm trained as a computer engineer. I design CPUs, but I do simulation. I do biomedical engineering. I'm an adjunct faculty in mechanical engineering. I do robotics. It's you can't just be a computer engineer anymore. You might get that fundamental training, but you have to be able to move across these boundaries, these interdisciplinary boundaries. That's really a critical skill that we have to learn. So whenever I get a student that says, I only want to do digital, I don't want to see any analog, I don't want to see any programming, I don't want to see, you can't be that way. You have to be open. I used to joke because I didn't like to write. I was like, I don't want to write. Well, now I'm editor-in-chief of the magazine. I write all the time. And that's a skill I had to build. You have to build these skills. And again, if you're not willing to try, and say, now I love it. Now it's like, now I know how to tell a story. And I think that that's part of it, is just because you don't like it now, if you keep trying and you try different avenues, just like a job, right? You go to a job and you're like, oh my God, I don't like this job. Therefore, I'm not cut out for engineering. I want to leave the whole discipline. And I tell people, you join a sports team, or you join a team, you train hard, you have losses, but do you quit the team when you lose? No, you don't. You just find a new position. You find new things. You find what fulfills you. And a lot of people forget that means bringing in what's unique about you, stay committed to what you like. And a lot of people think they have to sacrifice that, and that's sad.
So I was gonna ask you, you are a prolific writer, you are a prolific speaker on STEM advocacy. Considering you started out trying to fund your shopping habits What makes you so passionate about writing and speaking on this topic now?
The things that I thought were common sense or that were obvious to me weren't obvious to other people, So I realized that was something special. It was like I designed my Nerd Girls program over 27 years ago. And the whole concept was, young ladies weren't seeing role models that were successful engineers. They were, all the role models we had were long gone, or they didn't look like them. They didn't come from the same backgrounds. And they also thought that it was a very, mutually exclusive, you must be a pizza eating, cave eating, video gamer from the start. You can't like shopping, you can't like sports, you can't like dancing, you can't like art. And I got students to understand that no, your passions are what make you innovative and very special. And if we want mass-produced engineers that are just all the same, you're not going to have very creative and innovative problem solvers. And that message was, when I first came out, and people calling it Nerd Girls, I mean, oh my God, what are you doing? You're bringing women back. But when they saw what I was doing, they also recognized that, what we're doing for women is really good for all youth. It's not just a woman thing. And I always give the example of, gender equity in projects was one of the first things that I promoted. And people said, well, what does that even mean? I said, well, one of the projects they wanted me to lead was smashing concrete to test structural strength, or wrapping coils to, make a radio, things like that. And I was like, I don't want to do this as the faculty member. Why would another kid want to do it? So, and the analogy I give is, if I had a project saying, okay, everybody, boys, girls, we're going to design high heel shoes. You're going to hear flack about it, right? You're going to say, what? I don't want my boy to design high heels. And the guy's going to be like, I don't want to do this. But if we all of a sudden say, today we're designing sneakers, right? Gender equitable. Everybody wants to do it. Everybody understands the concept. And I think that that's part of the problem that we've had. And if you even look at toys, I have a little boy. And when I had my little boy, I was astounded at the difference in the toys, just the toys. And there was no market for girls' toys, right? Oh, let's make it pink and purple and that'll sell it. There were no mechanical engineering toys. There were no design toys. And I think we've seen this whole paradigm shift that's happened now for STEM advocacy. I did not go into engineering thinking that I would be an ambassador or a champion for women in engineering. I went in, I was hired. They didn't even know if I could teach. And they said, you will be a mentor for women. And I was like, oh, all right. They think, just because you're a woman, that automatically makes you nurturing and it automatically makes you a great teacher, which we both know is not true. And when I went in, guess what? There were no women. So who was I to get a mentor? So that's when I decided, okay, there's a systemic problem. And little by little, some of the things that I did made a big difference. And that's finally how one of my former Nerd Girls said, you need to write a book. You're telling everybody how to do it. Write the book. So I did. I wrote the book with her, Count Girls In. And that's essentially a parent's guide to how to raise gender equitable children and different careers that you might not even know exist for engineers and scientists.
I've known you for several years and I did not know that you wrote a book. I'm just learning this now. Can you tell me a little bit more about that?
Sure. So, it came out in 2019. It's now being translated to Korean. I'm I'm a rock star over in Korea. So it's essentially the best practices. So, you've heard many times that if you don't capture children's interests in STEM by the 8th grade, you've lost them. And that whole mindset of, introduce them to STEM later in life, at eighth grade, it is too late. And to me, it's like, well, why are we starting at 8th grade? Why aren't we starting from birth? So I give you practical examples. I used to plop my kid up on the counter and, we learned to measure and bake together and do things together. And yes, I made a big mess and some messy experiments, but he learned to measure. I mean, and he learned how to do things. He learned how to read. He learned how to technical concepts. So all these different things that you do, and again, relating to what he likes, the science, when we go to the ocean, talking about microplastics and pollution and animal life and things like that. You don't need to be a science or math expert and say, here's the math and science behind it. You need to just connect it to something they understand. And that's one of the biggest things is a lot of parents will come to me and say, how do I get my daughter into science and technology? And I'll say, well, what does she like? oh, she likes math and science. I said, no, 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 no. What does she like? Well, she, because does she do math and science in her free time? No, she's out shopping like me, or she's skateboarding or cheerleading, modeling, doing, sculpting, artwork. Those are the interests you want to connect back to the STEM, not the math and science. The math and science are tools. And I think that that's been part of the problem is we filter them very young. And we also tell kids they have to be the very best at math and science. You say that to a girl, that to her means I have to be an A+ student. You say that to a guy, a boy, C's good. So we filter them too early. And that's my other message.
I love this practical approach to this, that you look at what's in the world and you relate it to these concepts that could be daunting, or you're talking about trying to go one way and pushing through, but going through a different means. This is absolutely amazing. I've been a big fan of your work. What is the best way for people to continue to follow what you do, Karen?
Oh, well, there's the book, so you can always check that out. You can check out the Nerd Girls website, nerdgirls.com. We have, videos of young women role models up there, because from fields that, medical physics, physicists. We had the first Miss America contestant that did science as a talent. So there's just so many, careers that people don't even think about. Sports people who work with sports and designing for optimal performance for athletes. So we're trying to show these wonderful role models to people. So that's one way to do it, to take a look at that. The other thing is there's so many volunteer organizations within IEEE. Our student branches are always doing projects. Our IEEE site, humanitarian projects, they can get engaged and see what we're doing. And even our tri-engineering, that's one of my favorite. I use those as myself when I have to do outreach, because a lot of people think, oh, I want to get into outreach. How do I do it? Do not start from scratch. Do not, if it's already built, use somebody else's proven technology. So triengineering.org is a wonderful, wonderful resource.
You know what? That's a great idea. And I'll include links to those and to your book in the show notes below. This has been absolutely amazing, Karen. Thank you so much for taking the time to talk with us.
Thank you for having me. Have a great day.